As we wrap up this unit, we will learn about two more sets of trigonometric identities. We'll apply these new identities to evaluate expressions, verify identities, and solve trigonometric equations. Make sure you have your reference sheets handy, and let's get started. Our first new set of identities are the product to sum identities, and here is one of them. The product to sum identities are aptly named since they help us rewrite a product like cosine of alpha times cosine of beta as a sum of terms instead. Just like the power-reducing identities, the product to sum identities are useful in calculus, especially when integrating. Let's use some identities that we've already learned in this unit to verify one of the product to sum identities. We want to show that cosine alpha times cosine beta is equal to cosine of alpha plus beta plus cosine of alpha minus beta, divided by 2. If we start working on the right side of the equal sign, what could we do first? Which identities could be helpful? Notice that on the right side we have the cosine of a sum and the cosine of a difference, which we have identities for. Pause now and use the cosine of a sum and cosine of a difference identities to verify this product to sum identity. How did you do? After using the identities to rewrite cosine of alpha plus beta and cosine of alpha minus beta, we can simplify by eliminating the sine alpha, sine beta terms and adding the cosine alpha, cosine beta terms. Simplifying the 2 on the numerator and denominator leaves us with cosine alpha, cosine beta, which verifies the identity. The identity we just verified is one of 4 common product to sum identities. Take a moment and record these on your reference sheet. As an extra challenge, you can verify the rest of these in your lesson notes. For now, let's apply these identities to evaluate a trigonometric expression. In this example, we want to find the exact value of sine of 7 pi over 8 times the sine of pi over 8. Since this is a product and we don't know the sine of 7 pi over 8 or pi over 8 from the unit circle, this is a good opportunity to use a product to sum identity. Rewriting this product as a sum where alpha is 7 pi over 8 and beta is pi over 8, and then simplifying, results in values that we do know the cosine of. Using our knowledge of the unit circle, we evaluate cosine of 3 pi over 4 and cosine of pi and simplify to get a final answer of 2 minus root 2 over 4. Can you think of another way we could have solved this problem? Well, 7 pi over 8 is half of 7 pi over 4, and pi over 8 is half of pi over 4. So we could have used the half angle identity for sine for each factor in this product. The last identities that we will cover in this unit are called the sum to product identities. Again, these are aptly named because they allow us to rewrite a sum as a product. Let's take a moment to verify the identity sine of alpha plus sine of beta equals 2 times sine of alpha plus beta over 2 times cosine of alpha minus beta over 2. If we start working on the right side of the equal sign, what could we do first? Which identities could be helpful? Notice that we have the product of sine and cosine, which we have an identity for. We can use the product to sum identity for sine times cosine, where alpha plus beta over 2 is alpha, and alpha minus beta over 2 is beta. Pause now and verify this sum to product identity using one of the product to sum identities. After rewriting the product as a sum, we can simplify the alphas, the betas, and the 2's until we are left with sine alpha plus sine beta, which verifies the identity. The identity we just verified is one of 4 common sum to product identities. Take a moment and record these on your reference sheet. Again, as an extra challenge, you can verify the rest of these in your lesson notes. For now, let's apply these identities to verify a trigonometric identity and solve a trigonometric equation. In this example, we want to verify the identity cotangent x equals sine of x plus sine of 3x over cosine of x minus cosine of 3x. We can start by using some of the sum to product identities to simplify the numerator and denominator. Pause now and verify this identity. Let's see how you did. After using the sum to product identities, we can simplify a bit. Notice that we have 2 times sine of x plus 3x over 2 in the numerator and denominator, which can be canceled out. Simplifying the remaining terms brings us to negative cosine of negative x over sine of negative x. Now we can use the even-odd identities for cosine and sine to rewrite cosine of negative x as cosine of x and sine of negative x as negative sine of x. And finally, we can cancel out the negatives and rewrite cosine x over sine x as cotangent x, which verifies the identity. In our final example, we'll solve the trigonometric equation sine of x plus sine of 3x equals 0. How do you think we should start? Since we can't just isolate a single trigonometric function in this equation, our next strategy should be trying to solve by factoring. The equation is already set equal to 0, so all we need to do is figure out how to write the left side as a product. Good thing we have an identity that does just that. We can use one of the sum to product identities to write the left side as a product. Pause now and use the identities you've learned in this unit to rewrite the left side of this equation as a product in terms of sine and cosine. What did you end up with? After rewriting using the sum to product identity, we can divide both sides by 2 and further simplify within the parentheses. We can further expand the left side using the double angle identity for sine and the even-odd identity for cosine. Then simplify a bit more to get sine of x times cosine of x squared equals 0. Great job so far! Now that we have a product in terms of sine and cosine that is set equal to 0, we can set each factor equal to 0 and solve for x. To satisfy this equation, either sine of x needs to equal 0 or cosine of x needs to equal 0. Notice how simplifying with the identities made us end up with simpler trigonometric functions that will be easier to solve. Pause now and find the general solution to this equation. Using the unit circle, we can see that sine of x equals 0 at multiples of pi, and cosine of x is 0 at pi over 2, 3 pi over 2, and so on, which can be written as pi over 2 plus pi n. In general, we can say that x equals pi n, or pi over 2 plus pi n, where n is an integer. We can also simplify this answer a bit more. Looking back at the unit circle, we can see that all of the possible solutions are simply multiples of pi over 2. So we could also write our answer as x equals pi over 2n, where n is an integer. Nice work! Great work! Today we covered the product to sum and sum to product identities, which you should have recorded on your reference sheet. We also used these identities to solve problems and verify identities. Be sure to keep your reference sheet handy as you complete the lesson activities and online practice. See you next time!
Hey, hey.